All right, in 5.3a, we're going to look at finding trig values from any angle, not just an angle on our unit circle, but any possible angle. And it will start with a given point in their quadrants. So let's just try one of these. First one says at -8, -15. So that's a point down here in quadrant 3, where it's -8 over and -15 down, right? So what we're going to do is draw that vertical line in, and we're going to make a right angle with the x-axis, always with the x-axis. And then we're going to draw a diagonal to the origin. Now, there is an angle here from standard position that goes right here, right, all the way over here. That's angle theta. Now, what we're going to be dealing with, though, is what we call theta prime. Now, they're not the same angle. However, the trig ratios are the same. So for now, you can think of them as the same, and in a future lesson, I'll explain the difference. But for now, we're going to focus on the right triangle that we've created and where theta is. Now, notice theta is always, or theta prime, always with the angle with the x-axis. Okay? Also, when you draw your triangle, always with the x-axis. All right, and I'll show you what I mean as we continue on. You're going to see that these triangles always hug the x-axis. So now that we have established where theta is and our two side lengths, we can find our third side length by using good old Pythagorean theorem. So in this case, I have two sides, so x squared plus 15 squared is equal to our c squared, right? When you do the math, you will find out that c comes out to be 17. Okay, so you find the third side, and then we can put in our 6 trig functions. We can figure these out relative to theta. So sine of theta is opposite theta, -15 over the hypotenuse. Cosine of theta is the adjacent side, so -8 over 17. Tangent of theta is opposite over adjacent. Now, both of these are negative, so it will end up being positive, right? Okay, so now we can just do our reciprocals. So cosecant of theta will be -17 over 15. Secant of theta will be -17 over 8. And then cotangent of theta will be a positive 8 over 15. So we found our 6 trig ratios from a given point. Now, just a word of warning here. When you find a hypotenuse, the hypotenuse will always be positive, okay? This will always be positive because it's a distance. Now, your legs could be negative or positive depending where they fall in the quadrants, but the hypotenuse will always be positive for future reference, okay? Let's try another one. Look at number 2. First thing we want to do is plot our point. Well, where's -1, 1? Okay, I'm going to stretch it out here and make this -1 and 1 up be up here. So if that's the case, then I have a point, -1 and 1. And I'm going to draw the horizontal to make the right angle with the x-axis and then the diagonal to the origin. Now, my theta prime angle is right in here. Remember, it hugs the x-axis. And from here, I can find my missing side. So this is a +1, and this side is -1. Okay, and to find my missing side, this should be pretty simple. So 1 squared plus -1 squared is going to give me, what, 2? So the hypotenuse will be the square root of 2. That said, I can now find my 6 trig ratios relative to theta. This theta would be, okay, opposite would be 1 over the square root of 2. Now I do have to rationalize that. So it's square root of 2 over square root of 2 would give me the square root of 2 over 2. The cosine of theta is adjacent over hypotenuse. Again, we have to rationalize. So I have negative square root of 2 over 2. The tangent of theta is opposite over adjacent, so 1 over -1, so it becomes -1. Now let's just reciprocate these. So it's not cosine, it's cosecant. So cosecant of theta. Now, I just warn you, when you reciprocate something you've had to rationalize, go back to the one where you before you rationalize it and reciprocate here, okay? It's much easier. Otherwise, you're going to have to rationalize again. So if you reciprocate that 1 over square root of 2, you find out that the cosecant is the square root of 2. So as I do secant, again, I'm going to come back to this one, reciprocate that, and notice it will come out to be a negative square root of 2. And then cotangent of theta will come out to be a negative 1. Easy enough. All right. So let's move on to number 3. 5, negative 12. Let's think about what quadrant that's in. If the x's are positive, it has to be either 1 or 4, right? And the y's are negative, so it's down here. So x of 5, y of negative 12. So that means I have a point way down here. So we draw the vertical line with the x-axis, and then we'll draw in the diagonal. So this is negative 12, and that's 5. All right, and then where's our theta prime? It's right there. Now we can find our missing side using Pythagorean theorem. So it'd be 5 squared plus negative 12 squared gives me c squared. When you do the math, you will find out that c is 13. This is a common triple, Pythagorean triple, that you'll end up memorizing because we use them so often. So we'll find our hypotenuse of 13. Now we're set and we can do our trig ratio. So the sine of theta would be opposite over hypotenuse, so negative 12 over 13. The cosine of theta is the adjacent over the hypotenuse. The tangent of theta is equal to the opposite over the adjacent. Now let's do cosecant of theta would be negative 13 over 12. Now notice I put the negative on the top. Even though 13 is really not negative, the whole fraction is negative. I just keep the negative on the top. I don't move it to the bottom. It's just a preference, okay? So secant of theta would be 13 over 5, and then cotangent of theta would be a negative 5 over 12. All right? So we found our 6 trig functions. Notice what we had to do. We had to draw a triangle, label our sides, find the missing side using Pythagorean theorem, and continue from there. Let's try one more. Okay, this one has a positive x and a negative y. That means I'm down in quadrant 4 again. So let's see. I'll draw my vertical. So this will be negative 2. And this is the square root of 5. Okay, so there's my right angle. Draw it in, put in my theta prime. Let's figure out our missing side. So I'll walk you through this one. So square root of 5 squared plus negative 2 squared. Well, square root of 5 squared is 5, plus 4 is c squared. Well, that's 9 is c squared. So now if I take the square root, that means the absolute value is c is either positive or negative 3. But we know it's going to be a positive because it's a hypotenuse. So that hypotenuse is now a 3. That being said, let's find our 6 trig ratios. So the sine of theta is opposite over hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Now, I have to rationalize because I can't leave a radical in the denominator. So I end up with negative 2 square roots of 5 over 5. Now, let's reciprocate these. The cosecant of theta would be then negative 3 halves. The secant of theta would be 3 over the square root of 5, but we have to rationalize. So I'm going to have 3 square roots of 5 over 5. The cotangent of theta, remember the little trick, go back before I rationalize it and flip it there. Here I get the square root of 5 over 2, and the negative is still there. Okay? So you're going to be doing some of that for me today. Now the next section says find the values of the 6 trig functions of the angle theta. Now it gives us a little bit of a constraint. It gives us a cosine instead of a point or a specific trig value. And it does give us some indication of where the triangle falls. So let's try this. Look at this. Cosine of negative 5 over 4. Well, I know that cosine is the adjacent over the hypotenuse, right? Well, the hypotenuse can't be negative, so I know that that means that the 4 is negative, okay? This also tells me that it lies in quadrant 3. So if I draw my quadrants, quadrant 3 is down here. So if I draw in my triangle, it will be here. And then it would make sense because the 4 would be a -4. And the hypotenuse is 5. Now my job is to find the missing side. So if I do some Pythagorean theorem, now I'm going to have to do, I'm just doing b squared plus 16. The other side squared equals 25. So b squared would be 9, square root both sides. Absolute value of b is plus or minus 3. I know it has to be positive. Well, does it have to be positive? No, because it's not a hypotenuse on this one. So notice it is a line, it is a value down here that goes into the negative y's. So this makes it -3. So be aware of what's going on here. It can be negative when it's a leg. It can't be negative if it's the hypotenuse. Okay? Now we have everything established. We can find our 6 trig functions. So we'll have the sine of theta is the opposite over hypotenuse. The cosine of theta is -4/5. The tangent of theta is, let's see, opposite over adjacent. So negative over negative would be +3/4. Cosecant of theta is -5/3. Secant of theta, -5/4. And cotangent of theta is equal to 4/3. All right? Now, let's look at number 6. This one is a cosecant. All right, this is cosecant. So remember what cosecant is. It's the reciprocal of sine. So it's r over y, right? R over y. So r is our hypotenuse of these right triangles. And that means the y value is a 1 and it's positive. So it must be positive, right? Now it says here, here's our constraint. The cotangent is less than 0. That's fancy for the cotangent would be negative. That means your x and your y do not have the same sign. One is positive, one is negative. Well, I know if my cosecant's positive, that means my y is positive. So the x's must be negative in this case. So I'm looking at the quadrants and I'm deciding where is the x negative and the y positive. Well, that would be in quadrant 2. X's are negative, y's are positive, right? And that was my logic to get me there. We'll do some more of this in a moment. If you haven't quite gotten it, that's okay. Now, there's my stuff. Let's put in, we said r is 4, y is 1. So notice we have to find a leg here. We need to find the leg that falls on the x-axis. So let's look at this. This would be 1 squared plus b squared equals 16. So if I finish that, I find out that b squared is going to be what? 16 minus 1 is 15. Take the square root. Absolute value of b is either plus or minus the square root of 15. Now I have to look and decide. This is an x value in quadrant 3. So it's going to be the square root of 15, but it will be negative, correct? It will be a -15. So just be aware of that. It can be negative if it's a leg of your right triangle. Now we can find our 6 trig values. So let's do this. Not cosine, let's start with sine, like always. So the sine of theta is opposite over hypotenuse, which we should have known, right? Because it told us the cosecant of theta was 4. Oh, so sine would be 1/4, my bad. Now, cosine of theta would be the adjacent over the hypotenuse. Let's go ahead and do tangent of theta would be the opposite over the adjacent. So 1 over negative square root of 15. Rationalize this. So I get negative square root of 15 over 15. Cosecant of theta, not cosecant, I'm sorry, secant, running out of space, but secant of theta, when I rationalize this, it's going to be 4 square roots of 15 over 15. And then cotangent of theta would be, if I flip it over, it's just the negative square root of 15. All right, it's a little messy, a little squishy there, but you get that. Hopefully you're getting the idea. It becomes very repetitive in process. You just have to be aware that sometimes the legs can be negative, like we saw in these examples, okay? The y was negative on number 5, the x was negative on number 6. Okay, moving on to the next type of question. Since the terminal side of theta lies on the given line in the specified quadrant, find the values of the 6 trig functions of theta by finding a point on this line. So let's look at number 7 here. This one has a slope of 1 over 3. And we know it has a y-intercept of 0, right? Because it's basically a plus 0 right there. So we know it has a y-intercept of 0. And we know the slope is rise over run. So go up 1 over 3. And there I have my line. Now I can draw my line, but what I'm really focused on is my triangle right here with the x-axis. Remember, with the x-axis is what we care about. So what do we know about this triangle? Well, we know that right here is our theta prime. We know that the height of it is 1 and the width of it is a 3. We can find then we know it's in quadrant 1 because it tells us so right here. We can find the hypotenuse pretty simply. 3 squared plus 1 squared gives me what, 10? So the square root of 10 is my hypotenuse. It's always positive. It says find the values of the 6 trig functions. So here we go. The sine of theta is opposite over hypotenuse. So when I rationalize that, I get the square root of 10 over 10. The cosine of theta is 3 over square root of 10, so that's going to be 3 square roots of 10 over 10. I'm just skipping the rationalization, I'm doing it in my head. The tangent is opposite over adjacent, so 1 over 3. Cosecant of theta is the square root of 10. Secant of theta is adjacent, it's hypotenuse over adjacent, so it's square root of 10 over 3. And the tangent of theta in this example is just 3. Okay, now let's look at number 8. Now we couldn't just graph it like it is because it's not in slope-intercept form. So we've got to do just a little bit of rearranging here. So if I have 3y equals negative 4x plus 0, if I divide through it by 3, I will find out that my actual line is negative 4/3 x plus 0, right? So if I go to my graph, I'm going to start at the y-intercept of 0. And I'm going to go down 4, 1, 2, 3, 4, and over 3, 1, 2, 3. There's my triangle. Oh, and it says to do quadrant 4. Now you could have extended your line and done it in quadrant 3. Notice it goes into quadrant 3 and 4. I'm sorry, 2 and 4. But it does tell us to use quadrant 4, the triangle from quadrant 4. So we're going to use this triangle. We know it goes down 4 and over 3. If we find our missing side using Pythagorean theorem, this is a common Pythagorean triple, 3, 4, 5 right triangles. I know that the hypotenuse will be 5. So now I can go back and do my 6 trig functions. All right. If you want to pause the video and do this, I'm going to pause the video, put on my key, and then you can check your work. All right, as we continue on, let's look at this next type of question. This one is just asking you, state the quadrant in which theta lies. So the way that I would approach this is draw myself the 4 quadrants and start eliminating what doesn't work. So look at the constraint it gave me. It says the sine of theta is greater than 0. So remember, sine is y over r. And r is always positive, right? So if it's greater than 0, that means the y's are positive. So what quadrants have a y value that is positive? Well, we know it's either 1 or 2 because that eliminates 3 and 4. Now I look at where's the cosine of theta? Negative. Well, cosine is x over r. Well, we know r is positive, but if it's less than 0, that means my x's are negative. So my x's are positive in quadrant 1, so that means this is a quadrant 2 question. And that's all you have to do on these types of questions. Let's try the next one. Number 10. Okay, secant is r over x. So again, I'm focusing on x here. If it's less than 0, that means my x's are negative. So it can't be 1, it can't be 4. Cotangent is, let's see, it is x over y, and it's less than 0. Well, if x is already negative, we know that from here, and this is less than 0, that means my y's have to be positive. So it can't be quadrant 3 because y is negative and x is negative. So my answer on this one is also a quadrant 2 question. If you want to pause it and try 11 and 12, go right ahead. I'm going to continue on explaining it in case you need more support. Okay, look at this one. Let's think. Tangent of theta is y over x, right? It's greater than 0, so that means they have to be the same sign to be positive, don't they? So where are x and y the same sign? Well, that's in quadrant 4 and quadrant 3, so this eliminates 2 and 4. Then it's asking me about secant. Well, secant is r over x, and it says secant is less than 0, so x is less than 0. So where's x negative? That would be down here in quadrant 3. So eliminates 1, and that means our answer is quadrant 3. Last one like this. Okay, so cosecant of theta, you don't have to write out this step. This is just my logic as I'm getting there, okay? Cosecant is r over y. So it's really talking about the y value. If the y is positive, that means I can eliminate quadrants 3 and 4. Now, cotangent is x over y. So I already know that y is positive. And if it's saying it's greater than 0, that means they have to be the same sign. So that means that x must be positive also. So that eliminates quadrant 2, and my answer is a quadrant 1. All right, so this last section is focusing on the unit circle, okay? We're going to be getting our answers just from the unit circle. So you might want to pull that out. Let me pull mine up for you. All right, here's my unit circle. I'm just going to scooch it up here, right here for reference. Now, it says evaluate the functions just from the unit circle. So it's looking for cosecant of 3 pi over 2. All right, so let's look at where's 3 pi over 2. Here's 3 pi over 2 right here. All right, so cosecant, remember, is what? It is, cosecant is r over y, right? Okay, in the unit circle, remember r is always 1. What is the y value at 3 pi over 2? Well, the y value is negative 1. So then the cosecant at 3 pi over 2 is negative 1. Cotangent, number 14, is x over y. All right, so let's look at 3 pi over 2. Take the x coordinate over the y coordinate. What does that equal? That equals 0. If 0 is on top, it's equal to 0. Now it switches the angle here a little bit. It's saying, okay, let's look at angle 0. What is the secant at 0? Well, let's refresh. Secant is r over x, right? R is 1. What is the x value here? It's 1. So 1 is my answer. Then we're switching over to angle pi. Where's pi? Pi is over here at the 180 mark. And let's find that. Let's see. Cotangent of pi is going to be x over y again, right? X is negative 1. Y is 0 at this angle. Now, if the 0 is in the denominator, this is an undefined solution. Does not exist, basically. It's undefined. You can't divide by 0. Okay, one last one. This is taking us to pi over 2. Why not? Let's get all 4 corners, right? Pi over 2 brings me right up here to the y-axis. Cosecant, what is cosecant? It's r over y. Well, r is always 1 on the unit circle. And then I divide it by the y value, which is 1. So the cosecant at pi over 2 is 1. That's how you're going to work those problems. I hope that makes sense. Please let me know what questions you have when you get to class.